Okay, so we are going to first today talk about what a scatterplot is. All right, so let's think back to when we talked about quantitative data. Do you guys remember the most commonly used graphical display for quantitative data? What's the most commonly used in stats? Graphical display for quantitative data. The histogram. Yes, you did. All right. The histogram. That's the most common one that you're going to see, especially I'm hoping to teach many of you senior year for stats. Okay. Now, what we're going to talk about for the next few days is we're going to look at two quantitative variables at the same time. Okay. So two quantitative variables at the same time. And we want to know if there is a relationship or an association between these two variables. All right, and the way we're going to do that is by making something called a scatter plot. Okay? So here's a scatter plot. Now, a scatter plot, whenever you make these, and again, for this part of, for the SAT, you're not going to be in charge of making any scatter plots. All right, but when we get to stats, you're going to be tasked with making them yourself, right, using technology, of course. But the first decision you have to make is which is going to be your explanatory variable and which is going to be your response variable. Okay? Now you'll notice where I wrote those, the explanatory is on the x-axis and the response variable is on the y-axis. Okay? Now, in probably middle school, maybe even elementary school, you guys got your first taste of this when you talked about independent and dependent variables, probably with like science fair, all right? Independent and dependent variables, no? Ring a bell? No? Yeah. In science, okay? So in stats, we don't say independent and dependent. We say explanatory and response, all right? And you're going to hear me talk about this when we do examples, right? Where one variable explains the other. All right, we're going to ask ourselves those statements. Do we think year explains this or this explains year? Okay, so that's what we're going to have to decide. Now, what three things did we always have to remember when we describe a histogram?
Shape, center, spread.
Very good. Shape, center, spread, right? If you ever forget, always just look on like the right inside of your forearm and you'll see that's where we tattooed it, okay? Now, for the scatter plot, there are three things you have to remember when you describe a scatter plot. All right? Direction, form, and strength. Direction, form, and strength. So here's direction. Direction is positive or negative. I'm just saying, like, these are the options. Positive or negative, right? And this one you can see is negative. Okay, so positive or negative. That's direction. Okay, form. Form is linear, so like a line, or not linear. Curved is fine. Somebody say curved. Not yet. Don't need you yet. Okay. All right. So curved is fine. That'd be not linear. I would try to make it even simpler for you. The one that we want is linear. All right, this is what we're hoping for. We're hoping for linear because the stuff we're going to talk about on Friday, we can only do that stuff if you tell me the form is linear. All right, and then not linear. Curve, fine. Okay, everybody good? Okay, strength. Now, strength, there's really three options. There's weak, moderate, or strong. Okay? Now, this is probably the most subjective out of all of them. I think you guys will be pretty confident in deciding on your direction and form. You'll be less confident on the strength. Okay? Now, if you look at this one, and ignoring the size of the dots, right? Ignore the fact that the dot sizes are different. Do you see how these dots are really tight, close together? All right? When they're really tight and close together, that's strong. Okay? That's a strong association. When they're scattered, right? See how this kind of looks like a cloud? There's not really a pattern here, right? This would be weak. All right, let me show you another example of weak. Right? I try to make it weak and a barely positive. All right, moderate like a little closer together. Okay? Now, the reason that this isn't a big deal is when you get to stats in your senior year or in college, you're going to see that this strength can be defined by something called the correlation coefficient. Should write this down. Okay? The correlation coefficient. And the letter we use for that is the letter R, a lowercase r. All right? So when my students are doing this, that my seniors are doing this, they're making a guess. They're saying, I think it's moderate, or I think it's weak, or I think it's strong. But then we actually use technology to spit out what this letter R is, and their understanding of correlation coefficient will tell them, oh, you know what? Because of that R, it's actually strong, or it's actually moderate. Okay? So don't fret too much about strength, because when you get to later classes, you'll see that we have a way to quantify it. Okay? All right. Now, I already mentioned the roles of the variables, all right, the explanatory and the response. So explanatory is the x variable, the one that goes to the x. The way I think of it is x explanatory, okay? And response variable is the y. All right? You guys ready to try one?
I guess.
Excellent, let's do it. All right. So, I've given here a table of data where we have vehicles, their horsepower, and then their gas mileage. All right? So miles per gallon. All right? I've also given you a scatter plot. Now you'll notice that I have already decided on which variables are explanatory and which variable is response. Okay? I have decided that horsepower, or the size of a car's engine, explains their gas mileage. I'll repeat that. The horsepower, or the size of the engine in a car, explains their gas mileage, or their fuel economy, their miles per gallon. Okay? That was my decision. If you disagree, then you would change this. Okay? You would change it. You would flip them. All right? But you can't because you don't have technology. So we're going with that. Okay.
Would it still work?
You could still totally get the right answer. Yes. But you would be saying that you think it's the other way, that your fuel economy or gas mileage explains the amount of horsepower. Okay? Now, when you look at this, we need to be thinking about three things.
Strength,
No.
shape,
No. Direction, form, and strength. Shape, center, spread was so last week. Direction, form, and strength. Okay? So let's go with Adrian.
negative.
I want direction first, and he says negative. Great. Let's try, that's direction. Let's do form. So look back to your notes on form. Let's go with Sophia. Form. What do you think for form? Linear, I agree. Linear, very good. And then here's the hardest one, the most challenging one for strength. Let's see who's got strength. Okay, Yoshika. Strength. Weak. She's going with weak. All right, so I'm going to answer A. There is a negative linear. Now, Yoshika. Oh, Yoshika, I disagree. I don't think it's weak. I think
Moderate.
it's actually moderate. I mean, I think it's actually strong. But let's go with moderate.
Wait, how is it strong?
I mean, I think it looks pretty close together. I'm just letting you know. Okay? I think it's fairly strong. Okay. We'll go with moderate. Yoshika, right weak. Yoshika, right weak for yours. All right, if you agree with Yoshika, right weak. It doesn't matter. There is a negative linear moderate association between horsepower and miles per gallon. All right? So we have addressed all three things, direction, form, and strength, and we have put it into context. Context being that we have mentioned the names of the variables. So whenever you're doing this, I need to see those three things plus a fourth thing, the context. All right? If you just put there is a negative linear moderate association, period, you would not get full credit. All right? Give that context for the names of the variables. Okay, so what does this plot say about the fuel economy of a car? What do you think?
Oh, it's higher for the less amount of horsepower.
Can you try again with like a complete sentence?
No.
Okay. Yes.
The more horsepower it has, the less miles per gallon.
Excellent. I agree. All right. Now, I'm going to use some stats words in there to make sure that I'm not like pigeonholed or locked into that sentence, right? Because obviously there are going to be some cars where this is not true. So I'd say, I expect that as the car's horsepower increases, the fuel efficiency decreases. Now, could you say as the fuel economy increases, you expect the horsepower to decrease? Could you say that? Absolutely, right? The idea here is that they have an inverse relationship. One goes up, the other goes down. All right, that's what we're looking at here. So I was just trying to get you, Adrian, to say it in a sentence that we could write. All right, but your thought was correct. Okay, any questions on this example?
No.
No, everybody okay? Okay, great. Let's do another one. All right. So this table gives you roller coasters. All right, these are the names of roller coasters. This next column says drop in feet. This is the initial drop on these rides. You know how if you've ever been on a roller coaster, you go up, it cranks you up, and then you go down that first drop. All right, so you can see this is the height of that first drop. Okay? Last semester, I guess 2 semesters ago in May, we took the seniors to Fiesta, Texas, and I did the Wonder Woman ride. Oh my gosh, it was my first roller coaster in about a decade. I thought I had died because I handled it fine, but clearly I was like tense in the seat. So when I got out, I just like buckled, right? My hips were on fire. It was not good. All right. So roller coasters though, they're fun, right? Okay, great. So the duration, the last column, is how long the ride is. All right, how long the ride is. So we want to see, is there a relationship between that first drop and the length of the ride? And I think there is, right? I think the longer, or I guess the higher that first drop is, the longer the ride will take. Let's see. What do you think? All right, let's hit the 3 things. Direction. Nicole, direction. What do you got? Positive, negative. Positive, right? I agree. Positive. Okay. Form. Ooh, form. Yeah, let's go with Diego. Form. Non-linear. He's going non-linear. Okay, fair enough. And then I'm going to go with Jimena for strength. Weak. See how you guys said weak on the last one? Right? See, I think this one is weak. I think there's more scatter. There's more spread. So I agree it's weak. I'm going to go with linear, though. I think it's linear.
What?
So there is a...
Wait, can we say none?
Of course. Of course. These are your notes. There is a positive.
Would it be wrong?
No, it's not. That's the thing about stats, man. There's lots of different answers. There is a positive. I know, this is amazing. Positive. I think linear, weak association between the height of the first drop and the duration of the ride.
Why do you think it's...
Well, the reason I think it's linear is because I think that it looks like there's a lot of scatter because we don't have a lot of data points. I bet if I got maybe 10 more data points, it would start to clean it up a bit, make it look more linear. And also, the reason I say linear is because if I want to do all this fun stuff called linear regression, which I'm going to teach you on Friday, it has to be linear. All right, I can't do linear regression if I don't think the form is linear. So I want to do all the fun stuff, so I say it's linear. Now, what's nice, Adrian, is the back of my mind, I know there's a check, right? Even if I say this is linear and I'm wrong, there's a thing that we're not really going to get into. But there's a thing in stats called the residuals. All right, if I check the residuals plot, it will confirm for me if I should be doing all this work. Or it will say, you know what, you shouldn't be doing this, and you should stop. So I always have that in the back of my mind. All right, it's all good. You don't need to know that. Okay. Now, let's move to the homework.